Hello everyone, welcome to the study of ordinary difference equation. We are looking at the linear difference equation with the constant coefficient. So today's focus, we are looking at an equation whereby the roots are real and distinct. We are given the second derivative of y with respect to x plus first derivative of y with respect to x minus 12y is equal to 0. So we expect our solution to be of this form. Y is equal to c1 exponential m1x plus c2 exponential m2x. Here, c1 and c2 are what is referred to as essential arbitrary constant, and m1 and m2 are the root of our quadratic equation. So to solve this, and given ODE, which is linear with this, and is the second order, we let your y to be equal to exponential mx. Then from here you get your y prime. Y prime is the same as dy over dx. So you differentiate this. When you differentiate exponential mx, the result will be m multiplied by exponential mx. Then you get your y prime, y double prime, which is the same as second derivative of y with respect to x squared. So you differentiate this again. So you are going to have m times m will be m squared exponential mx. So we shall have m squared exponential mx. So we have obtained our this second derivative of y and our first derivative. So we are going to substitute there so that we obtain m squared exponential mx plus m exponential mx minus 12 exponential mx. This is equal to 0. Clearly you can see here we can factor m. M is common, so we can factor exponential mx to be left with m squared plus m minus 12. This gives you 0. And note that exponential mx can never be equal to 0. So meaning that our value in the bracket, it is the one which is equal to 0. So m squared plus m minus 12, it is the one which is equal to 0. So this is a quadratic equation whereby we have the product as negative 12 and the sum as 1. So you ask yourself, what are the two numbers which when you multiply it will give you negative 12, and when you add them, they are going to give you 1. So you have 3 and 4. 3 times 4 is 12. To make it negative, it implies that 3 is the one which is negative, so it is negative 3 and positive 4. So that when you have negative 3 plus 4, it will give you 1. And when you have negative 3 times 4, it will give you negative 12. So we factorize our quadratic equation, which is m squared minus 3m plus 4m minus 12. This is equal to 0. You can factor in these two, we factor m so that we get m minus 3. In the last 4, we factor, in the last two terms also we factor 4 m into minus 3. This is equal to 0, which implies that m minus, here you have m, you can write it this way, plus 4 into bracket m minus 3. This is equal to 0. So it implies that your m, either m minus 3 is equal to 0, meaning that your m is equal to 3, or m plus 4 is equal to 0, which means, so this one we can call it m2, meaning that our m2 is equal to negative 3, our negative 4, sorry, from here, negative 4. So our M1 is 3 and our M2 is 4. So our equation was of this form. Y, our solution is M1x plus C2 M2x. So we have got our M1. Our M1 is 3. Our M2 is negative 4x. So that is our solution, which we can check, and they want us to do that. Yes, check. We are given this equation, y double prime plus y prime minus 12y is equal to 0. So we want to check whether our working is correct. Our y, we have found it to be C1 exponential 3x plus C2 exponential negative 4x. So we want to get y, the single prime. First of all, y single prime, you differentiate this. We will give you 3C1 exponential 3x minus 4 C2 exponential negative 4x. Then you differentiate it again to get y double prime, which will give you 3 times 3 will give you 9 C1 exponential 3x. Then you have negative 4 times negative 4, which will give you plus 16 C2 exponential 4x. Then you substitute, you come back here, you substitute the value of y double prime, y single prime, and y in this equation to obtain the following. So you will have our y double prime, we have found it to be 9 C1 exponential 3x plus 16 C2 exponential negative 4x. Our y single prime, which is there plus, it is 3C1 exponential 3x minus 4C2 exponential negative 4x. Then minus 12y, our y is here. So you have 12 C1 exponential 3x minus 12 C2 exponential negative 4x. This will give you as what? We are checking the working. So you have 9C1 exponential 3x plus 3C1 exponential 3x minus 12C1 exponential 3x. So 9 minus 12 minus 12, it will give you 0 plus 16C2 minus 4C2 exponential negative 4x. That will give you it will give you 12. 16 minus 4 is 12 minus 12 C2, that will give you 0, which is equal to 0. So meaning that our working is correct. So our solution, given you the y double prime plus y single prime minus 12y is equal to 0, our auxiliary solution is this: y is equal to C1 exponential 3x plus C2 exponential negative 4x, whereby C1 and the C2 are what is referred to as essential arbitrary constants, and 3 and negative 4, these are the root from the quadratic equation which we have formulated above, which are real and distinct. Thanks so much for your time and for studying the linear difference equation of second order with the constant coefficient with me. For further studies, kindly tune on to my YouTube channel so that you may continue learning together with me. Bye bye. See you in the next video as we continue doing more areas